Today we will discuss Bayes' theorem. Often the probability analysis begins with initial probabilities. Then we obtain an additional information from a sample or special report. And then we use this information to calculate the posterior probabilities. So we have the prior probabilities, we obtain new information and apply the Bayes' theorem and calculate the posterior probabilities. We will explain this through an example. We will look at this example. Consider a manufacturing firm that receives shipments of parts from two different suppliers. A1 denotes the event that a part is from supplier 1. A2 denotes the event that part is supplier 2. And currently, so A1 denotes the event that part is from supplier 1, and A2 denotes the event that part is from supplier 1. Now we only have two suppliers. We can have more suppliers, 3 suppliers, 4 suppliers, but in this case we only have 2 suppliers. Currently 65% of the parts purchased by the company are from supplier 1, and the remaining 35% are from supplier 2. So if a part is selected random, then probability that randomly selected part is from supplier 1 is 0.65. Probability that randomly selected part is from supplier 2 is 0.35. This must add up to, so this must add up to 100%. We could have more suppliers, but here we only have 2. So then probability of A1, 0.65, probability of A2, 0.35. So then A1 denotes the event that part comes from supplier 1, and A2 denotes the event that part comes from supplier 2. Probability that randomly selected part comes from supplier 1 is 0.65, and probability that randomly selected part comes from supplier 2 is 0.35. Now we receive this information, which is the quality of the purchased parts, varies with the source of supply. Now this gives a quality rating. Now how can we interpret this table? If you look at supplier 1, %96% from supplier 1 are good, 2% are bad. Now look at supplier 2, 95% of the parts are good, 5% are the bad. Now how can we write these probabilities? Now these are the conditional probabilities. So if part comes from supplier 1, probability that it is good, 0.95, 0.98 if it comes from supplier 1. And if it comes from supplier 1, probability that it is bad, 0.02. If part comes from supplier 2, probability that it is good, 0.95. If a part randomly selected, if part comes from supplier 2, probability that it is bad, 0.05. how can we write those probabilities? So probability that part is good given comes from supplier 1. So we can define two more events, say G, randomly selected part is good. B is randomly selected part is bad. Do we know what's the probability of G and probability of B now? We don't know because we can have good parts from supplier 1 and supplier 2. We can have bad parts from supplier 1 and supplier 2. So we can calculate those probabilities later, but these are the conditional probabilities. So what is the probability that part is good, given it comes from supplier 1, which is 0.98. So what's the probability that part is bad, given comes from supplier 1, 0.02. And what's the probability that part is good, given it comes from supplier 2, 0.95. And what's the probability that part is bad, given comes from supplier 2, 0.05. These are conditional probabilities. So again, we have two suppliers. A1 denotes the event that part is from supplier 1. A2 denotes the event that part is from supplier 2. And we can have good parts and bad parts from each supplier. Now, if part comes from supplier 1, probability that it is good, 0.98. If part comes from supplier 2, probability that it is good, 0.95. So then these are the conditional probabilities. Given part comes from supplier 1, probability that it is good, 0.98. Probability that part is bad, given it comes from supplier 1, is 0.02. And probability that part is good, given comes from supplier 2, 0.95. Probability that part is bad, given comes from supplier 2, 0.05. Which is G denotes the event that part is good, B denotes the event that part is bad. These are the conditional probabilities. Now we will draw the tree diagram to understand it better. So we have two suppliers, so the part can come from supplier 1 and supplier 2. 65% of the parts come from supplier 1 and 35% comes from supplier 2. We can get good parts and bad parts from each supplier. Now, how many outcomes do we have? And what are those outcomes? As you see, we have 4 outcomes. What are those outcomes? So randomly selected part can be good and comes from supplier 1. Randomly selected part can be bad and comes from supplier 1. Randomly selected part can be good and comes from supplier 2. And randomly selected part can be bad and comes from supplier 2. So we have 4 outcomes. And how do we calculate the probability of those outcomes? So, such as this is A1 intersect G. Part comes from supplier 1 and it is good. How can we calculate this probability? We have G given A1 and probability of A1. If you remember the conditional probability, what is G given A1? Probability of A1 intersect G divided by probability of A1. We know probability of G given A1 0.98. We don't know A1 intersect G, and we know probability of A1 0.65. So probability of A1 intersect G, how can we solve this for A1 intersect G, which we multiply these two to solve that A1 intersect G. So that's why probability of A1 intersect G is 0.98 times 0.65. And the same thing, probability of A1 intersect B. Which is part is bad and comes from supplier 1. Now you multiply probability of A1 times probability of B given A1. This is another outcome which is part is good and comes from supplier 2. Now we multiply these two, which is we multiply probability of G given A1, A2 times probability of A2. And the other outcome is probability of A2 intersect B, part is bad and comes from supplier 2, 0.05. So these are the sort of 4 outcomes. A1 intersect G, part is good and comes from supplier 1. Part is bad and comes from supplier 1. Part is good and comes from supplier 2. Part is bad and comes from supplier 2. We have total 4 outcomes. And how did we get 0.637, which is 0.98 times 0.65? And how did we get 0.013? Probability of A1 times B given A1. And how did we get 0.3325? Probability of A2 times G given A2. How did we get 0.0175? Probability of A2 times B given A2. 0.017. This is a tree diagram. We have 4 outcomes, and what is the sum of the probabilities of these 4 outcomes? It must be 1. Now let's verify 630 plus 0.013 plus 3325 0.0175. It must be 1. Sum of the probabilities of all experimental outcome must be 1. Now this is the question. Now suppose that the parts from the 2 suppliers are used in the firm's manufacturing process, and then the machine breaks down because it attempts to process a bad part. So we know that part is bad. So given the information that the part is bad, what's the probability that it came from supplier 1? Which is a conditional probability. Given that it is bad, what's the probability that it came from supplier 1? And what's the probability it came from supplier 2? What is given? So remember, we have 4 events total. Now how can we write these two probabilities in terms of these 4 events? We have A1, A2, B, and G. A1 denote the event that part is from supplier 1. A2 denote the event that part is from supplier 2. B denote the event that part is bad. G denote the event that part is good. Now how can we write this one? So given the information that the part is bad, what is the probability that it came from supplier 1? Probability of what? Some conditional probability. But what is given? Which information do we know? We know that it is bad. That it came from supplier 1. So this is probability of A1 given B. This is what we need to calculate. We need to calculate probability of and given the information that part is bad, given it is bad, what's the probability came from supplier 2? A2 given B. So remember, like, probability of A1 given B and probability of B given A1 are two different things. What is probability of B given A1? Probability that part is bad given it came from supplier 1. That probability is given here, which is this one. Now if part comes from supplier 1, what's the probability it is bad? 0.02. But here we need to calculate something else. We know that part is bad. So part attempts to process, so the machine breakdowns occurs because it attempts to process a bad part. So we know now part is bad. What's the probability came from supplier 1? It is bad. Probability given it is bad. What's the probability came from supplier 1? Given it is bad, what's the probability came from supplier 2? Now how can we calculate these probabilities? This is the conditional probability. Assume we don't know the Bayes theorem, but we know the conditional probability. This is what A1 intersect B, given probability of B. Do we know what A1 intersect B is from the tree diagram? 0.013. But now what is probability of B? So remember, we can have bad parts from supplier 1 and bad parts from supplier 2. We can get bad parts from supplier 1 and bad parts from supplier 2. We have 4 outcomes. Part is good and comes from supplier 1. Part is bad and comes from supplier 1. Good and comes from supplier 2. Bad and comes from supplier 2. And we need to calculate probability of B. So now, how do we calculate probability of an event? If we know the sample points in that event, we can add up the probabilities of the sample points. Since we have two outcomes, that is bad n comes from 1, bad n comes from supplier 2. Probability of B is probability of A1 intersect B plus probability of A2 intersect B, which is sum of what's the probability that randomly selected part is bad, which is probability of A1 intersect B plus probability of A2 intersect B. To 6-2. Now the other question, what's the probability part comes from supplier 2 given it is bad? We know it is bad. What's the probability came from supplier 2, which is probability of A2 intersect B divided by probability of B. Now the probability of B is probability of A1 intersect B 0.0130 plus probability of A2 intersect B 0.0305. Point 573738 for this one. 377 to 38. And if you add these two, it must be 1. Why? Because given part is bad, you only have two options. Either it's from supplier 1 or supplier 2. So sum of those must be 1. This provides the formulas for two event case. But you can have more than two events. You can have like n events, because such as assume you have 5 suppliers. Then you have then this will be, if you look at the tree diagram, if you had 5 suppliers, which you can get good and bad parts from each supplier, then you will have 5 branches here. And this is the formula for more than 2 suppliers. So now we discuss the base theorem. You can always let me know if you have any questions.